Problems on orthogonal trajectories. Orthogonal trajectories for the Cartesian forms and polar forms. I already discussed how to calculate the orthogonal trajectory of the given family of curves. The given curve containing f of x comma y comma c equal to 0. C is the arbitrary constant. Then you have to eliminate c by doing differentiation with respect to x. Then that equation becomes as f of x comma y comma dy by dx equal to 0, and replace dy by dx by minus dx by dy and solve the differential equation. Then automatically we will get the orthogonal trajectories of the given family of curves. Now like that I am considering one problem here. Find the orthogonal trajectories of the family of curves x square plus y square equal to a square. Given family of curves, solution x square plus y square equal to a square. Differentiating with respect to x on both sides. Why should I do differentiation? Here a is the parameter, then you have to eliminate that a. If you want to eliminate that a, means you should do the differentiation with respect to x. Then differentiation of x square is 2x and y is nothing but differentiation of y square is 2y dy by dx, and this a square is constant, this is 0. Then you take the 2 common, then it becomes x plus y dy by dx equal to 0. Means after eliminating a, I got the one differential equation x plus y dy by dx equal to 0. This is the first step. In finding orthogonal trajectories, you need to calculate one, first eliminate the arbitrary constant. Then if you are eliminating that arbitrary constant, automatically we will get one differential equation. After getting this differential equation, you replace dy by dx by minus dx by dy, because orthogonal trajectory means we are calculating perpendicular curve to the given family of curves. Means suppose if the family of curves, if it has the slope m means dy by dx, means you need to calculate perpendicular slope. Now if dy by dx is slope, then perpendicular slope is minus dx by dy. Now that's why I am replacing here dy by dx by minus dx by dy. Then I am substituting here x minus y into dx by dy equal to 0. Then x equal to y dx by dy. Separate the variables, x dy equals to y dx. Then after again you separate the variables, y terms one side and x terms one side. Then 1 by y dy minus 1 by x dx equals to 0. Now integrating on both sides, integral 1 by y dy minus integral 1 by x dx equals to c. Now log y, integration of 1 by y dy is nothing but log y minus integral 1 by x dx is nothing but log x. Now both all terms are in all equations are means terms in terms of logarithm. That's why I have taken c also in terms of logarithm. C is unknown, log c is also unknown. Now log y minus log x equals to log c. Then log a minus log b formula is log y by x equals to log c. Then on cancellation of log, we are getting y by x equal to c or y equal to xc. Means now we are calculating the orthogonal trajectory of the family of curves. Means the family of the curves is nothing but x square plus y square equal to a square. This is the equation of the family of circles. Now what I got here, this family of circles are perpendicular to the y equal to x. This is nothing but straight line. Means these both are perpendicular curves. Now this is the y equal to xc is the curve which is perpendicular to the given family of curves x square plus y square equal to a square. Then this is orthogonal trajectory of the given family of curves. Now second problem on orthogonal trajectories. Show that the system of confocal conics x square by a square plus lambda plus y square by b square plus lambda equals to 1, where lambda is the parameter, is self orthogonal. Means you have to show that here this system of equations x square by a square plus lambda plus y square by b square plus lambda is self-orthogonal. Self-orthogonal means now after eliminating the arbitrary constant, we get the one differential equation. Then that is after getting the differential equation, anyhow we need to substitute dy by dx by minus dx by dy, means replace dy by dx by minus dx by dy, means before replacing and after replacing, if both equations are same, then both are self orthogonal, means both are perpendicular to each other, means the slope both are m1 into m2 equal to minus 1, like that. We both lines are perpendicular in straight lines, already we got in geometry that type of concept. Now first of all, you consider the family of curves x square by a square plus lambda plus y square by b square plus lambda equal to 1. Here lambda is the parameter. Now what I will do, we cannot eliminate lambda directly. Now I will differentiate on both sides. After that I will calculate separate values a square plus lambda and b square plus lambda after doing differentiation. Now in the previous problem, what I did there, I calculated directly, I eliminated a when you are differentiating, but if you are differentiating, again we are getting lambda, means from this after doing differentiation, I will calculate separately a square plus lambda and b square plus lambda. Again I will substitute these two values in this equation, like that I will eliminate. Now how should I eliminate? Please observe this one. Differentiating with respect to x on both sides, then differentiation of the first term x square differentiation is 2x by a square plus lambda, that is anyhow that is constant, plus differentiation of y square is 2y y dash by b square plus lambda equal to 0. Differentiation of constant is 0. Now you can take 2 common and send that side, it becomes, the equation becomes as x by a square plus lambda plus y dash by b square plus lambda equal to 0. Then you take the LCM a square plus lambda and b square plus lambda. After taking LCM, again we are sending that side, directly I am writing here. Then x into b square plus lambda plus y dash into a square plus lambda equal to 0. Now in this I will calculate separately lambda value, you have to focus on lambda. Then lambda I am taking common here, b square x I am multiplying here, b square x plus a square y dash. Now I am taking lambda common, lambda into x plus y dash equal to 0. Then lambda into x plus y dash equals to, you send that side, minus of b square x plus a square y dash, lambda equal to minus of b square x plus a square y dash by x plus y dash. This is lambda value. This is equation number 2, the first given family of curves, that is nothing but equation number 1. Now after getting lambda, what I will do, I will calculate from using this lambda, I will calculate a square plus lambda and b square plus lambda. I will calculate these two values separately. Now lambda equal to, I got like this. Now adding a square on both sides, then it becomes LHS side a square plus lambda, a square minus b square x plus a square y dash by x plus y dash. Now you take the LCM here, LCM is x plus y dash, then this into a square x plus a square y dash minus, multiply with minus b square x minus a square y dash, minus a square y dash plus a square y dash cancel. Then x is common here, a square plus lambda equal to a square minus b square into x by x plus y dash. Now this is the a square plus lambda value. Similarly, we can calculate b square plus lambda also. Now what I will do, for that lambda, adding b square to equation number 2 on both sides. From that to b square plus lambda equal to b square minus b square x plus a square y dash by x plus y dash. Again LCM x plus y dash, then multiply with b square to this LCM, b square x plus b square y dash minus b square x minus a square y dash. Now my plus b square x minus b square x cancel, b square plus lambda equal to, again y dash is common. When you are taking y dash is common, then it becomes minus of a square minus b square y dash by x plus y dash. This is b square plus lambda value. Now what I will do, a square plus lambda value and b square plus lambda value I will substitute in equation number 1. Then equation number 1 can be written as x square by a square plus lambda value I am substituting here, a square minus b square into x by x plus y dash, minus, anyhow it is minus is there, that is why I am directly writing minus y square by a square minus b square into y dash by x plus y dash equals to 1. Then here x square is there, here x is there, x cancel, y square, in this y square is there, y cancel. Then after modification what I will do, x into x plus y dash by a square minus b square minus y into x plus y dash by a square minus b square y dash equals to 1. Then here I will consider, directly I am writing here, a square minus b square is the LCM, and again I will send that side. Then directly I am writing here x into x plus y dash minus y by y dash x plus y dash equal to a square minus b square. I have taken 1 by a square minus b square is the common, otherwise you can send a square minus b square that side. Then here also again x plus y dash is common, then it becomes x minus y by y dash into x plus y dash equal to a square minus b square. Means like this, after eliminating a square plus lambda and b square plus lambda, I got the equation, this is the differential equation, I will consider as this is 3. Now once again I am writing before substitution, before replacement of y dash by 1 minus y by y dash. Once again I am reading third equation, after eliminating the arbitrary constant lambda, x minus y by y dash into x plus y dash equal to a square minus b square. Now I got like this. After that, for getting the orthogonal trajectories, you have to replace dy by dx by minus dx by dy. Means dy by dx means here y dash and dy by dx both are same. Now replace y dash by minus 1 by y dash, because minus dx by dy is nothing but minus 1 by y dash. Then I am writing here, the first one, when you are replacing y dash by minus 1 by y dash, then first bracket becomes as x plus y dash. The second bracket becomes as x minus y by y dash equals to a square minus b square. This is equation number 4. Now observe this one very carefully. If 3 and 4 both are same, 3 and 4 both are same, so x square by a square plus lambda, y square by b square plus lambda equal to 1 is self orthogonal. Means both are perpendicular to each other. Means before replacement and after replacement, if both equations are same, then that type of system of equations, means family of equations are nothing but perpendicular to each other. Perpendicular to each other means self orthogonal, means that the curve is orthogonal to itself only, right? Now this is nothing but like this we can show that the Cartesian form family of curves self orthogonal.